This is Chris Barnes. It's the 12th of January 2018. I'm here at Labman with Joe Savage. Joe, can you just introduce yourself and explain what you're going to demonstrate for me today?
Yeah, I'm Joe Savage. I'm going to make a part on the milling machine. Go through all the steps from getting the drawing to actually finish off the part.
Right. Now, just to be clear, you've actually made the part. We're going to go through how you made the part. Yeah. So, for the purpose of anybody watching this, Joe's actually made the part, and he's now going to go through the process, the life cycle of how he did that. So when you come to a machine like this, what's the sort of safety aspects you've got to be aware of?
Obviously there's a mat on the floor, just got curled up so I'm going to ship over it. Coolant guns, air guns, there's pipes out to over.
Right.
Put the swath on the floor, and then you on the floor.
So can you take us through some of the signage that's on it and some of the instructions that's on it and tell us what it's for?
Yeah, so we've got sign here, which basically at the end of it saying switch off the machine, shut it down, turn the air supply, just so there's no air going through the system overnight.
Yep.
Warnings which come with the machine just basically say...
And are these interlocked? So
these are interlocked, yeah, so that door won't open unless you turn the door lock off, but when it's turned off it's locked anyway.
Right, and that stops it from opening.
Side doors are locked as well, so when it's running you can't get inside at all.
Okay, and what's the XYZ?
This is, so if you use the sacrificial bed, for example, which we will do later on, which I'll show you, just so you remember your offset, if you didn't leave it overnight.
Right.
Also we could jump on the machine, you can write your offsets down there, just so you know where you were working at, where your zero was.
Okay.
This one, just don't press the stop button when it's changing tool, because there's just an error on the XYZ machines where they crash. It loses where it is if you stop at mid-tool change.
Right.
This is the XYZ code for the vice acting.
Right.
So basically that's just the 0, 0 of the vice.
So it's like 0 point?
Yeah, so if you're going to use the vice and you want 0, that's what the coordinates put into the acting.
Okay.
That's if you've got any spare tools, because it's got a tool changer in there.
Right.
16 tool changer. If you want any more tools, like what we are there, and you just place them in the tool rack there. This is just if you have any issues, what to do if you have an issue, who to see, where to write it down.
Okay. That's great. So if you can just explain how you started the job and what you had to do, where you got the drawing from, what drawing you used.
We have a manufacturing task board, which is our local internet, which does like the jobs. So the next job on was this one, which is life off. For the big life robot out there. So it's just a 10mm aluminium plate, a few holes in it. Not too hard, but. So first of all, I have to switch the machine on.
Right.
So first you switch the air on. Like that.
Is there any safety issues you've got to be aware of when you're using the air?
No, as long as it's turned off, overnight it's fine, just when you turn it on. It just puts air back into the tool changer. Once because it's locked, there's no compensation.
So it's a vacuum sort of tool?
Turn the machine on, you switch this on to on. And that's turn the machine on. Yeah, you put this servo button on the side.
Yep.
That just puts the computer, connects the computer to the milling machine.
Right, okay. So before you obviously start doing that, you've got to do the programming side. Can you take us through what you do there?
Yeah, so to do the programming,
And are you actually in charge of this machine, or? Because I know people are given
machine. Danny's machine. So on a Monday, he will have to clean this machine down.
Right.
The vacuum near it, make this stuff cool and stuff like that.
Do you have a machine or anything you have to look after?
I have a little workshop. So
okay.
So programming the milling machine, we use a software called CNC.
Yep.
So on CNC, all the parts have a name and number. So what we do first is we import the part. Just go by going file, import, SolidWorks, because that's the CAD system that we use. So once we get it, we find it comes in like this. So that just shows our part ready. I've got it set to 0, 0, and you see there. Just so
it's at the top.
It's at the top. So I really remember when I'm doing it on my work.
So your start point's the top left at all times,
Always use top left. Then what you do is you have to extract the surface. So at the minute you can't just click on that circle there. You have to actually extract it as a line. So what you do is you add a new layer, which is extracted there. And then what you would do is, using the tools on the side, you extract the surface edges, which I've already done. So when you do that, it goes into blue lines. So it shows your program.
Alright, so that's
just that's all
that's
the work
profile.
I do, So first of all I would drill the holes in the bed. So I'd use the bike first, putting the aluminium in the bike.
Yeah.
And then I drilled the holes.
Right.
So doing that, I put on tool paths, drill hole wizard.
So, just explain to us, would you set everything up in the computer first and then load the machine, or would you load the machine then work on it?
You can do any way, it doesn't really matter.
Right.
As long as you know where you're going to work. So, because you don't do any offsets until you're actually on the machine.
Yep.
So you can put it on the sacrificial bed, you can put it on the bike. So it doesn't matter, you could do it. So you can do all the programming first and then do it in there.
So for the purposes of this, can you obviously finish off showing us on it there and then just show us on it, even if you put a scrap bid in or something like that, just to show me.
So first of all, I would do the holes, so hole wizard, and then all you do is you select the holes. Next, centre drill drill.
So you select the tool.
Yeah, and then you would go on centre drill. You choose your tool. So if that's the right tool, tool 1, which is a centre drill. If it wasn't, you go on the tool changer, which shows all the different tools. So once you've done that, you'd go back.
Then do you have to manually load this one?
No, this one's 16 tool changer.
It's already loaded.
Tools are in there, yeah.
Okay.
Then I'll do my drilling. So it's a 3.3 drill, hole in these. So what I would do is I'll drill them a 3. So when I'm holding it down to mill round it, I can put a 3 mil drill in, and then I'll drill out and then a 3.3 later to tap it M4.
Ah, right, okay.
So I'll select a 3 mil drill, which is there. And then I'll just click OK, and you go next. Go off. Yeah, you put your minus Z, which is how deep you want to go. So,
so from the
10
0
mil material. Yeah, so you'd go like, say like 11 mil, just so you're all the way through. Peck drill cycle, just so it's pecking, so he's taking swap out.
So how far?
And that's the actual finish. And then it'll go up here. So you click on your hole, it shows you're going to drill them 4 holes.
Okay.
When I've drilled them 4 holes, I will then move out of the bike onto the sacrificial bed, where I drilled the same hole pattern in the sacrificial bed, but I drilled them at 2.5.
So it's not you would, you actually have done, because you've produced that component,
So I drilled them 2.5, tapped them M3, then used them 3 bolts, I would hold my aluminium down to the sacrificial bed. Once that's held down, you then do the profile, which, as you can see here, starts off the work, comes in, round, and goes round twice, leaving a nice finish. So to do that, you do mill profile, start, you want to go outside the line. Then so I've started there, you click your end point, which is there, and it's the red line all the way around.
And would you cut one straight away, or would you sort of...
No, so what I do on here is I right click, choose your tool, so 6 mil cutter for example there. Choose your depth, so minus 10.5.
Take it down in layers.
Yeah, and then at the end, so that's just if you want to go down in levels or ramps, that shows levels. And then on this tool here,
so what might be the consequence if you just try to take it all off at once?
The tool's going to snap, you're going to get a bad finish. The tool's going to burn out. So on here where it says rough depth, if you click on that, you put so that's how many mil per pass. So I put 1 mil if you want to do 10 passes at 1 mil. Leave on side, that just leaves it leaves a mill on the side, you put 1 in there.
And is there any benefit to doing more passes than less passes? Obviously
it'll be quicker.
Tool not snapping.
It'll be quicker if you do less passes, but you have more chance of your tool snapping. At the time you reset the tool, put it in, save time is doing a lot of passes. But then you just click next on that, finish on that, and then you get your profile there. Then to get that onto the PC, all you would do is you have a memory stick in there, take that out of there, hit it here. And all you do is right click on.
Oh, so you're taking it from there,
and then, out of there.
So it's not connected.
They're not connected. Right. Yeah, but hopefully there will be one.
Yeah, I know. I was going to one yesterday. It was.
Yeah, the one down there. And then you just post all, put it on the memory stick, load it here.
Okay. So then coming to this, so once you've done that, once you've got your
program,
once you've got your material in, and you're about to go, would you prove it first with the tool going round on a?
You can do that, yeah. So
For
example, can you just turn this on, you set the hole, that just takes a couple of seconds to do that.
Right.
That just basically it knows where everything is.
So that's, I can see it going on the tools. So is that the actual one that you've done?
Yes, that's the actual finished part,
So there's the holes in, it's the edge lid. So you've got the edge finish. And did you burr the edges?
Yeah, deburr them using a sanding block.
Right. So you just use that, okay. And with the holes, would you ream the holes out at the end?
So the holes you usually deburr them, they're over there.
Yeah, no, that's fine,
Just going around them, just take the sharp edge off. So once we've got the off the memory stick, all we're doing here is we program, program, open, and then for example it's called life off, so there you can see my program that I did yesterday, life off. So all you would do is click one of them, open file.
Do you ever have a situation where it goes into error?
You could do, so say you pull your memory stick out too quick, and you've only got the program on there, you'll have either the name of one of the programs, so you'll click go and it won't run, it'll just stand still. So the program's in there.
Sorry.
So then what you would do next is set your material. So first hit the vice. All I would do is just move the bed over closer.
Yep. So you just manually
Moving the bed over. Just see if we can find this. And for example, all of the just will open the vice up,
Yep.
2 parallels in there, place that into the vice, tightened it up, and then what I would do is get my centre. I got my centre tool, which is tool 1, which is this one.
Yep.
Put it into the corner because the material was oversized.
So it's picked out of the console into the
into the tool changer, out of the tool changer into the spindle.
Do you ever have any trouble with that? Does it work?
So I was like, for example, I've crashed it before where
Yep.
the tool changes come out, and instead of it going down, stopping at a certain point to get the tool, it just went carried on, goes straight down and smash the tool changer.
Right.
You know, but sometimes it just errors, sometimes you click stop or you click go. Sometimes you can do that.
Okay.
So when I was setting this machine, this piece of work up, I always get my material oversized.
Yep.
So I set the 0, 0 in the corner, knowing I have enough work to do. Obviously, drilled the first 8 holes in there.
Yep.
Then I drilled 8 holes in the sacrificial bed. So
Right.
again, I set a different 0, 0, so I'll show you in a
And
minute.
is that just a standard sacrificial bed you just put on?
Yeah, just aluminium bed. Skim
Yep.
it down now and again when it gets too rough, like it's getting a bit rough now.
Alright, yes.
Yeah, so then drill that, tap that, get the aluminium billet into there,
Yep.
screw it on with bolts, and then you do your last program of milling round. So to do your, before you would run it, you do machine setup and you have a checklist. And that won't run until they are all yellow or green. If they're red, it won't run. So I tried to click run now, it wouldn't work. So all it basically is, the first work one is your offsets. So for example, that was my offsets yesterday using the bed. So when I was milling round, that was my offsets. My offsets for the vice were these ones here, when I was working on the vice.
Yep.
So
I've got a critically low battery, so
Yep.
that's great.
Yeah.
So how long does it take to run the piece through?
So from start to finish, we're drilling the hole, drilling the bed,
Yep.
milling round, probably take about 45 minutes.
Right,
to
okay.
have the part finished.
And was there any problems when you did it?
No, that's absolutely fine.
Okay. And then how do you close it down? How do you sort of end the,
So I take the work out,
sequence?
defer it,
Yeah.
use the coolant gun, give the machine a wash down, and then I'll go and give it back to the project leader where they will sign it off on the manufacturing board,
Yeah.
how long it's took, and then I'll go and get the next job.
Right. And just before we finish, what PPE do you need when you're working on a machine like
You
this?
just need safety glasses on.
So just your safety glasses like you've got now, so everything's as you should be. Okay. What about closing the computer down and switching
So
everything
at
off?
At the end of the night, all you would do is board, back,
Yep.
what we call shut down there, click
Right.
shut down, then you turn the air to the side, turn the switch off on the side where we turned it on,
Yep.
lock the computer, that's it, it's ready to get to work and do.
Okay.
All the tools that you have left out, just put them away.
And so how many?
Switch the
Just to be clear, how many tools were used in the production of that one component?
So we had the centre drill, the drills, the end mills, milling round,
Yeah.
burring tools, it had tap holes in it, so taps.
Right. Did you take any measurements when you?
So when we first set the vice, we have to use
Yeah.
the DTIs
Right.
to clock the vice and just to check that then coordinates are right. So we type them in,
Okay.
put the DTI in, make sure it's 0 when it's going round.
Is there any way you can measure the flatness of it?
We can't, so when you travel the DTI across the vice, the thing of the vice, if it stays on 0 or moves, you know, if it stays on 0 across the whole vice, it's flat. If it doesn't, then it's not,
Right.
it's not flat.
Okay.
Also, when we're setting the Z up, use
Yeah.
calipers just to set like to make sure it's on 0,
Alright.
and then we also use vernier calipers to check the size at the end.
And what's that machine for?
So when we're setting a new tool up, place it on here first.
Yeah.
How do we turn it around? Turn it on, click 0 against that, lift it up, take that out.
And then you know your
For
0
example,
point.
Put your tool in there,
Yep.
put it onto that, check what number was on the screen, type that screen at the Z offset.
And then you can take an offset on
and
that.
then, yeah, and then you don't. Then it's already set up so it knows how far away from the bed it is.
Okay.
You know that.
That's great. Is there anything else from this job that is worth noting? When you were progressing it, was there any problems with it? Any issues?
No problems. The only problem was when I first got the job,
Yeah.
tried to do the program on CNC, the part wasn't there safe. Tried to go and get the part safe from the project leader.
Right.
So I could put it in the one CNC CAD program and that.
Okay, and then what happened to the drawing once you finished with it?
Give the drawing back to the project leader and then they can rather keep them, get rid of them.
Right.
Because they always have, this is the second copy, they always have
Yeah.
an original copy.
And do you use coolant fluid when you're doing the job?
Yeah, cool all the time.
Right. And what happens to the swarf and everything when you finished? How do you tidy up?
Inside here, use coolant gun, wash
Yeah.
all the swap out.
Yeah.
It goes into an auger screw at the bottom.
Right.
So the auger screw pumps that through, into a bag
down there.
down there, which we clean up on Friday.
and
Like,
that-
we'll give them a week.
And where do you put your scrap? Do you recycle?
So we
Do
got
you?
in here, we've got workshop, aluminium swab, plastic swab for
Yeah,
the
yeah.
normal bin,
Yeah,
then
yeah,
we've got
yeah.
any like aluminium chunks from the recycling bins down the bottom.
And you recycle aluminium if it can be used again.
Yeah.
Okay. So what condition would you leave the miller in when you leave it?
So
What
all
state?
switched off, cleaned
Right.
down, tools put away, ready just in case someone else, I was off tomorrow for say, someone
Yeah.
else could jump on. So we won't leave any work in there.
And you have to book the machines out when you work on them.
Yeah, so what we're doing at the minute is someone's resourced the machine for 4 weeks at a time.
Right. Okay, no, that's great. Again, this just for the purpose of anybody watching this is the third assessment of Joe on milling, and I'll take the evidence, I'll put it in your portfolio, and I'll reference it accordingly.